Let's solve today's POTD, greatest sum divisible by 3. So we are basically given an array and we need to return the maximum possible sum of elements of the array such that it is divisible by 3. So in this test case, the author said that if you take 3, 6, 1 and 8 and add them, then it's 18, which is divisible by 3, and this is the maximum you can get. Some other possible sums are like 3, it is also divisible by 3. 9, it is also divisible by 3. 1 plus 8 is also 9, and then 5 plus 1 is also 6. So but we have to take the maximum one. Similarly, in this test case, there is no possible way in which you pick some element and add them and you get the sum as divisible by 3. And in this case, if you take 3 is one possible answer, 6 is one possible answer, 2 plus 4 or 3 plus 2 plus 1, and 4 plus 4 plus 1, 9 is also possible, and 9 plus 3, 12 is also possible. So the maximum one is 12. So the constraint is 4 into 10 power 4, and num_sci could reach till 1e4. Okay, now if I think for some greedy solution, then the best that I can do is I can divide all these numbers and get their remainders. So there will be only 3 possible groups. One will be 0 remainder group, one will be 1 remainder group, one will be 2 remainder group. And then 0 ones can be combined with themselves, like the sum of the all elements whose remainder with 3, which is 0, should be added. And now comes the case where remainder is 2 and remainder is 1. Now I can either combine them within themselves, like there are 6 elements having remainder 1, then I can add them together, or I can combine them with the elements having remainder 2. And one more possibility is I combine the elements having remainder 2 within themselves. So let's see, let's say that I have 5 and 5 remainder 3, 5 modulo 3 is 2, so this belongs to the 2 remainder group. And another one, let's say we have 3 fours. So if I add these 3 fours, I get 12, and if I add now I cannot combine these two 5s in any way such that they are divisible by 3, because there are only 2 elements. I need at least 3, and if I have 3 5s, if I have 6 5s, then I can think of something. So the only option left is combining it with this group. So 5 plus 4 is 9, plus 5 plus 4, 9, 18. So in this case, what I can see is combining the 2th group with one group gives us more answer. One more possibility, let's see if this is always true. So another, if in place of these two 5s we have 2 2s, 2 mod 3 is also 2, and we have 3 4s. Now in this case, if I combine these 3 4s, I get 12, and if I combine these 2 plus 4 plus 2 plus 4, which is 12, so in this case they are equal. So I cannot for sure say which one to choose. So the greedy solution is not going to work, because I cannot think of a possible greedy way in which I can decide that I have to group them within themselves or I have to group them with others. So this will fail. But if I just Now if we think in terms of dp, then for dp the constraints, we have to think for some proper state, otherwise it will give tle. I can also do one more thing, that um, uh, if I just apply a take not take dp, then either take it or not take it and keep on adding it. Now the sum will increase, like I have to somehow know that when I reach the end of the, when I have checked all elements, I have completed the take not take dp. In the end, when I hit the base case, I have to somehow decide that is this sum possible. So if I keep another state for sum, then it will give tle, because nums I is 1e4 and there are this much element, so 4e8, this multiplied by this is 4e8, so 4e8 is going to give tle. But one more thing that I can think of is I don't need to keep the sum, I just need to keep the modulo of the sum, because uh, if I have, currently I am at this number, I added 3 mod 3 is 0, then 0 plus 6 is 6 mod 3 is 0, then 0 plus 5 mod 3 is 2, then 2 plus 1 mod 3 is 0 again. So as a result I can clearly say that this entire sum is divisible by 3. And now you might ask, then but I don't need to give the length of the number of such elements, I need to return the exact sum. So basically what I can do is, if the remainder in the end is 0, then whatever I have considered till now, whatever path I have decided, that is true. So I will return 0, and in each step I will, in each take step I will add them, and as I return 0 from the previous state, so this number plus 0 becomes this number itself. But if it is not 0, then what I can do is I can return -1, and if it is -1, in take case I won't add the current number. So if I code it up, then it will become more clear. Now let's define the db function, memoization function, and the sum will remain inside integer. I don't need to use long because 4e8 is, it can fit inside integer. Now if int is greater than equals to n, then if remainder is equal to 0, I return 0, else I return -1. Now not take case, not take case is where I simply skip the current element and remainder remains as usual. Now take case, so in take case, if let's assume that I I have added the current element in take, so I will move to the next index, and my remainder will, new remainder will become this. If temp is not equals to -1, then my take will become b of ind plus temp. So if the remainder is 0, I will return 0, then here it is not -1, then I will add it with the current element, then I will return the max of take and not take, and the next next guy will see that if it's not equals to -1, then I can take it, so it will propagate and I will get the answer. For example, in this case, if I take 3, then if I first I will take 3, then I will take 6, then let's say that I don't take, let's simulate the given example only. I take 3, I take 6, then I don't take this, then I take this, then I take this, and then I reach the end. And while while moving from here to here, I have updated my remainder, and my remainder is now 0 once I am out of the bound. Now I return 0, then I go to this index. While returning, the recursive call will return. So while returning, I will see that it's not -1, so I will add 8, then I will return 8. Then when I am here, 8 is not equals to -1, so I will add it with 1, it becomes 9. Similarly, in this way only this thing will, and when the final function will return me the maximum uh, possible sum, which is divisible by 3. So I just need to return f of 0 comma 0. One more thing, I have not used the dp table. I have to use the dp table. So vector of int a 2D array dp with n as the first dimension, and the second dimension will be 3 for 0, 1, 2, and let's assign all elements as -1. If dp of ind and m is not equals to -1, it means that I already have the value, I don't need to recalculate it. Otherwise, in the end, I will simply return it and memorize it. I think we are good to go. Accepted. Let's see. Oops. 41531. Okay, 13. How is it 13? Oh, one more thing. In case of not take also, if not take is -1, then I don't need to take is equal to 0, and take is -1. Then if temp is not -1, then take will be updated, otherwise take won't be updated. And if not take is -1, return -1 E9. So regarding the fix that I did, Why this one was wrong? Because in this take the element is 0. So in case, let's assume that not take gave -1 and temp gave me -1. So it means that there is no such possible way in which I can get the remainder as 0, either from the take side or from the not take side. For example, in the test case, uh, having this 4, I cannot get, either I take it or if I don't take it, then if I don't take it I will get 1. Okay, but anyhow, the problem is that if I give it 0, and let's say that the not take branch gave -1 and temp also gave -1, then what I am doing is I am returning the max of 0 comma -1. In this way, if the branch is invalid, still I am taking it, because now the branch is no more invalid because it's not -1, it's 0. And one more thing, the if the dp element remains -1, then it will keep on recalculating the value, so it will also give TLE in larger test cases, because -1, the dp element is already -1, and if I set it with -1, then if the second time the function is called, it will again run these things. So it's better to change it to something more appropriate. So what I did, I changed it to -1e9. Now if it is invalid, then it will become, if it is invalid, then it will remain as -1e9, and then I will return -1e9. So dp element will become, let's say that not take is also -1e9, so dp element will become -1e9, which is not -1. So the next time if some function calls it, then he will understand that this particular value is pre-computed and I have the value equivalent to -1e9, so I won't recalculate it. And also the path is invalid because it is -1e9. So the next guy who will be using this function will say, okay, I don't need to take this path. But if it becomes 0, then it is no more -1, because in this case I decided that -1 will be my uh, element which will decide whether it's an invalid path or valid path. I hope it clears the doubt.